Hey there, students. It's Mr. Rhett. I thought I'd pop my face in here and say hello. So some of you have had some trouble with the balancing equations task, and it's a hard thing to do. It's a hard thing to learn. So that makes sense. I just threw it at you with a slideshow and no video or explanation or anything, just to see if you guys could figure it out on your own. But it's hard, so I'm going to do some examples now. Okay. So the basic idea here is when you have a chemical reaction, you have the products on the left side and you have the reactants on the you have the reactants on the left side and the products on the right side. And the chemical formulas of each compound are given. And for example, in number 13, which is not one of the questions you have to do, I'm using it as an example. This is silver oxide. You should know how to name that from last week. And on the right side, it's being split apart into separate parts. So we have silver by itself and we have oxygen by itself. So that's kind of what the reaction is. And we're going to get more into types of reactions later. But basically, all you need to know is that you're starting with silver oxide, and then it's becoming silver and oxygen separately. And the important thing here is you have to have the same number of each atom on each side of the equation. So on the left side of the equation, there are two silvers, but on the right side, there's only one silver. And so in order to fix that problem, what we do is we put a coefficient in front of each compound or element to fix the amounts so that we have the same amount on each side. So if there are two silvers on the left side and we want there to be two silvers on the right side, we just put a 2 in front. And now the number of silvers are balanced. Oxygen has 1 on the left side and 2 on the right side, and so we want there to be 2 on the left side as well. So I put a 2 in front of silver. Now that actually caused a problem because when I put a 2 in front of silver, now there are actually 4 silvers on the left side because there were already 2 here, but then we're multiplying it by 2, so now there are actually 4 silvers. So that actually messes up this coefficient. So I'm going to change that to a 4. And I think it should work now. So we've got, let's see, 4 silvers here, 4 silvers there. That's good. And then we have 2 times this oxygen. We have 2 oxygens, and we have 2 oxygens there. So I don't need a coefficient here, and I'm just going to put a 1 because it doesn't change the amount of oxygens. So just to double check, 2 times Ag2 equals 4 silvers, and 2 times just oxygen by itself equals 2 oxygens. That's the left side. And then on the right side, we have 4 times silver by itself equals 4 silvers. And we have 1 times O2, which is 2 oxygens. So look at that. We have the same number of silvers and oxygens on both sides of the equation. And so now the equation is balanced. And that's a really important thing to do in order to figure out how to actually do chemical reactions. If you have the silver and you have the oxygen and you want to actually decompose them into these parts, you have to do it in the right proportions, and you figure out those proportions by balancing the chemical equation. That's the whole point of this. Okay, let's do the next one. So in this case, we have phosphorus and oxygen, which are being combined, and then on the right side, it is phosphorus oxide. And so you can see that there are 2 phosphoruses and 5 oxygens on the right side, but there's only 1 phosphorus and 2 oxygens on the left side. So let's see. There's a couple different ways. Let's start with the phosphorus. So if I want there to be 2 phosphoruses, I'm going to put a 2 there. But we might have to change that later, as you saw in the last question. Okay, oxygen. This is a little weird. There's nothing I can multiply O2 by to get 5 oxygens without using a decimal, and you can't use decimals. So actually, what I need to do is I need to figure out a number that I can multiply this by, and another number that I can multiply this by, so that we have the same number of oxygens. Well, think about what is the smallest number that both 2 and 5 go into, and the answer is 10. So if I multiply this by 5, I'm going to have 10 oxygens. And if I multiply this one by 2, I'm also going to have 10 oxygens. But the other thing that happened here is when I put the 2 in front of this compound, it also applies to the phosphorus. So now there are 4 phosphoruses. So I need to change this one over here to a 4. Okay, and let's double check. 4 times P equals 4P. 5 times O2 is 10 oxygens. That looks like 100. I'll just put a oxygen, just to be clear. And then that's the left side. On the right side, 2 times P2 equals 4P. 2 times O5 equals 10O oxygen. So there you go. The equation is balanced because we have the same number of phosphoruses and oxygens on both sides of the equation, 4 and 10. Last one, this is a really hard one. There's a lot of stuff going on in this question. So basically we've got, this is actually carbon dioxide and this is water. You guys should definitely know what water looks like. You might know what carbon dioxide looks like. So carbon dioxide and water are combining to form this. This is some kind of gas. Let me just look it up. C6H12. C6H12O6. That's glucose. Sorry, it's not gas. That's actually sugar. So this is basically carbon dioxide plus water combines to make sugar with a little bit of extra oxygen gas floating around. Anyway, you don't need to know that. You just need to know how to balance the equation right now. So oxygen is really complicated because, look, there are 4 places in the equation where oxygen appears. So I'm going to leave that for later. I'm going to focus on the parts that are simpler. Why don't we start with carbon? Okay, on the right side of the equation, there's 6 carbons, and then on the left side, there's only 1. So I'm going to put a 6 here to balance the carbons. I might have to change that later depending on how everything else goes, but we'll see. Hydrogen, there's 12 here and 2 here. So I need to multiply that by 6. 6 times 2 is 12. So now the hydrogens are balanced. Let's check the oxygens. Okay, 6 times O2, that means there are 12 oxygens here and 6 oxygens here. So in total, there are 18 oxygens on the left side. And then on the right side, we have 6 here and 2 here. So that's 8. So they're not balanced. So we need more oxygens on the right side. Fortunately, we have this oxygen all by itself. So it's really easy to just put a number in front of O2 and it won't affect the carbon and the hydrogen. So what did I say? We have 18 oxygens over here and only 8 over here. So we need, let's see, that's 6. If there's 6 oxygens in this compound, then there need to be 12 oxygens here to make it all balanced. So I'm going to put a 6 there. And I think that's going to work. Let's write it out to double check. So on the left side, we have 6 carbons is 6C. We have 6 times H2 is 12 hydrogens. And then oxygens, we have 6 times O2, and then we also have 6 times O. So that's, I'll just put O for ox. So that's 12 and 6 is 18 oxygens on the left side of the equation. Let's double check to make sure the right side has the same number. Okay, so we have C6. We didn't actually put a number here. Well, this is 1 actually. If you don't need to put a number in front of a compound, you can just put a 1. 1 times C6 equals 6 carbons. 1 times H12 is 12 hydrogens. And then for oxygens, we have 1 times O6, ox 6, plus 6 times O2. So that's 6, that's 12, and that makes 18. 18 oxygens. Once again, same number of each atom on both sides of the equation. And that's it.